guys, today we're going to have a tutorial video regarding in our subject, which is Math World. We're going to tackle different topics which includes patterns, sequence, Fibonacci sequence, golden ratio, packing problem, word population, and the angle of rotation. So let's start. So for our first topic, we're going to discuss pattern. First, let us define pattern. Pattern is formed by different shapes. It is a regulatory in the world, in human-made design, or in abstract ideas. It is said that the elements of the patterns repeat in a predictable manner. So basically, that's the definition of pattern. Now, we're going to have a examples to further understand what pattern is. So, um, we have some examples for the patterns. In the first example, it consists of shapes. So we need to find the next shape for this pattern. So as we can see, the pattern for this one is arrange to circle, triangle, square, and go back to circle. So logically thinking, it should be square because of the pattern here. So definitely the answer will be square because of this. We have the pattern here, 1, 2, and 3. And then it goes back to 1, 2. So therefore, this will be 3. So, simple as that explains the pattern. So, for the example number 2, as you can see, I labeled it 1, 2, 3. And then we have some mathematical signs here, which is the minus, addition, multiplication, division, and then goes back to the negative or the minus sign. So, I will label it here 1 and 2. So, just like the first example, the answer here will be multiplication because of the pattern negative, and then will be positive, and then it will be the multiplication. This will be 3. So that explains the patterns. We will proceed to our next topic, which is a sequence. Sequence is a particular order in which related events, movements, or things follow each other. So basically, it's like a pattern, but it doesn't repeat. So we have a formula for sequence. It is a sub n equals to a sub 1 plus the quantity of n minus 1 and d, which is the common difference. So the common difference is the distance between each number in a sequence. So to further understand it, we're going to have an example. So we have some example here. So for example number 1, we have a sequence of 1, 4, 7, 10, 13, and 16. So we are going to find the next number for this sequence. So using this formula, we are going to substitute the values for the formula. So n, we're going to substitute n to this term. So we're going to find the 1, 2, 3, 4, 5, 6, 7. Seventh term. We're going to find the seventh term in the sequence. So we're going to substitute this n to 7. So a sub 1 is number 1 plus the 7 minus 1. So the common difference for this sequence is 3. So you can see here, 3. 1 plus 3 is 4. 4 plus 3 is 7. And 7 plus 3 is 10. So our common difference for this sequence is 3. So we just need to solve this so that we can find the seventh term. So 7 minus 1 is 6. So 6 times 3 is 18. So therefore our answer for this sequence is 19. So the seventh term in the sequence is 19. So next we will proceed to another topic which is under sequence, the Fibonacci sequence. Fibonacci sequence is a set of numbers that starts or a 0 followed by a 1 and proceeds based on that each number is equal to the sum of the preceding two numbers. So this is an example of the Fibonacci sequence. So the example for the Fibonacci sequence is here. In the definition a while back, it is said that Fibonacci sequence starts with 1 and or a 0 followed by a 1, which is this, and then proceed based on the rule that each number is equal to the sum preceding two numbers. So in order to get the next number, we only need to add these first two terms or first two numbers. So therefore the next number will be 1, and then the next number will be 2, and then 3, 5, 8. So our next topic will be golden ratio. Golden ratio is a special number found by dividing a line into two parts. It often symbolized using phi or phi. So we have a sample problem here for the golden ratio. So suppose that you have a box container that is 39 inch long and 45 inch wide. Find its golden ratio. So there is a formula in the golden ratio, for the golden ratio. Phi is equals to A over B, which is A is the long and the B is the wide. So we need to substitute these values to the formula. A is equivalent to 39 inch long over 45 inch. So the answer will be 0.867. So this is the golden ratio of the box. So our next topic will be angle of rotation. Angle of rotation means turning around until you point in the same direction. So basically that's the meaning of angle of rotation. So for now, here are some examples of how to find the angle of rotation of a certain object. So for angle of rotation, we have a formula. 360 over n, which is n is the total side of an object. So for the first example, which is the fan, the figure of a fan, we will use the formula 360 over the total side of this fan, which is 4. 1, 2, 3, and 4. 4 equals 90 degrees. So this is the angle of rotation of a fan. Now let's proceed to the next one. We'll use again the formula, which is 360 over, we have a total side of a blade, which is the 5, 1, 2, 3, 4, and 5. So 360 divided by 5 is 72 degrees. So this is the angle of rotation of a blade. So next is the word population. Word population is the total number of people on Earth. So basically, in solving population problem, we are finding the total or exact amount of people living in a specific place. So here are the examples for word population. So in the first example, um, we need to find the A. So we have a formula of A is equals to P times E over R and T, wherein E is a constant. So we need to substitute these values to this formula. So A is equals to 500 times 2.718. Then the rate of change is 0.06 and then 24 hours. So just solve this using your calculator. 500 times 2.718 is 2. So you will get an answer of 2110.03. So that is the value of your A. So now let's proceed to the number 2. So in the problem number 2, we're going to derive a formula. So first, let's substitute the values. So A is 13,000 equals to the missing, which is P, and then times 2.718 raised to 0.12 and 7 days. So here we need to solve this first. So 13,000 plus P, and then the value that you will get from your calculator. So you will get 2.316. So in order to get the answer, we need to divide 2.316 so that it will be cancelled here. And then the P will be isolated. So we just need to divide 13,000 from 2.316. So the P is equals to 5,613.13. So that's how to get the population. So for our last topic, which is the packing problems. Packing problems are a class of optimization problems in math that involves attempting to pack objects together. So here are the examples for packing problem. So we have a problem here for the packing problem. How many bricks each 8 inch by 4 inch by 2 inch will be required to build a wall that is 22 feet by 3 feet by 2 feet? So first, we need to identify the volume of the bricks. So V is equals to 4 times 8 times 2 inch. These are all inch. So the volume of the bricks is 64 inch cube. So now we need to identify the volume of the wall. So same process. 3 feet times 22 feet and 2 feet. So 3 times 32. So this 132 feet cube. So we need to convert this feet cube to the cubic inch. So we need to multiply this to 12 inch over 1 feet. So by solving it, we're going to have 228,096 inch cube. So now we're going to divide the volume of the wall to the volume of the bricks to identify the bricks, the total bricks that will be required to build the wall. So 228,096 inch cube divided by 64 inch cube will be 3,564 bricks, total bricks. So this is the final answer.